morning. I think Nalin, how's your day been?
It was good, thanks.
Good. Start with me. Hello. Can you hear
Hello.
me? Yeah, good. Got the booklet. I think all set up. Probably give it another minute or two and get started. I think some of them joining halfway through as well. There's some schools they have still English trial in the morning. So some of them joining after 11 or 11:30. All right, we'll slowly start it because the first section is just about a bit of the understanding of how it works. Probably you know what it means. Just a quick understanding. So you can see the main sections of the exam, functions and graphing. That includes like all the graphings we did, including linear, quadratics, cubics, codic, everything inclusive in here. And then algebra, you need all the basic algebra as usual. And then calculus, including all the differentiations, applications, as well as the integrations. And last section is the probability. And mostly most schools had SACs for this one as a SAC one. It really depends. And some schools they include the calculus, bit of calculus in the SAC one as well. And then mostly SAC two based on the calculus. The last one is the SAC three. I hope all of you got your SAC marks and keep them ready. And then you can easily calculate your percentages approximately at this stage. So which is, you can see unit 3, usually 20%, but schools can slightly change over. If they realize unit 3 assessments are a bit longer than unit 4, so they can increase the percentage. It depends on the school. But overall, the SAC marks must be 40% or 40 out of the total weaker marks. And then you can see the exam 1 and exam 2, all together going to be 20% plus the 40%, which is the 60%. So that's how SAC is going to be 40. Exam total is 60. You get the out of 100%. So within this 40, you got something at this stage already. So you can't change over, which is all you have target is out of this 60, get the highest possible marks. Out of 60, get the highest possible because you can't change this one anymore. All right. How about all of you? Just read through the checklist. I mean, this is a basic checklist. Can you just, if you printed or maybe if you're doing on the screen, read over and tick the ones you actually done that already, or you're happy with it. Or if you think still you haven't done that particular section, put a question mark. So if you think you've done it, put a tick. So go through this page fully, and I'll give probably a minute. Just read all the way on the page number 3. Dylan connected, Dulaj, you can hear me?
Yeah.
Perfect. Just read through and put ticks or maybe question marks, which is at least you know that you have to do that before the exam starts. Then ask you questions, so just make sure complete the full page. I mean, this webinar is more towards like I'm not gonna keep explaining things, like we gonna go through it together. So we do questions. Yeah, so we're doing the questions together. So which is you had to work it out, get the answers, I'll explain the concepts. So it's like collaborative work. And let's see, I mean, this whole booklet contains how many questions you have. All together, I mean, sort of like 107 questions, but we'll see. I don't want to rush it too much, but I'll try to do as much as we can. Yeah, that's a plan. Sound with me. When you're going through it, was there any tricky sections you have, or have you done all of them? Anything you waiting for?
Do you mean like content?
Content-wise, like there's a checklist, eh? So when you
Yeah.
read the checklist, anything like you feel, oh, I should go through it. I need to do this step. Anything you feel like in the list? You done the past papers? Yeah,
Yeah.
all of them? 2016 to 2023?
No.
How many you did?
I did like to like 2018.
Up to 2018? Or
Yeah.
from 2018? Okay, up to 2018.
Like,
Cool. Have you done any of the NHT papers? Northern
yes.
Hemisphere? Yes.
Yes.
Some of them?
All of them.
All of them? Okay,
Yeah.
good. Yeah, I mean, if you feel like you're running low with the time, in that case, maybe skip the exam ones, because they're not too bad. You can do any time. But exam twos, maybe focus on those ones. Even if you're running out of time, pick the questions, read the full paper, and if you realize anything tricky or something new, only do those questions rather than times in them. Yeah?
Yeah.
Cool. And also, it's a good thing I explained in the classes as well, most of you. Read examiners' reports on the past exam papers. Yes, when you do the past exam papers or NHT, you're reading the answers. Yes, but keep a habit of reading the answers even though your answer is right. The reason, this time you're lucky enough to get it through. But when you read the report, it might say, okay, some students do this little mistake in there. And it might be advantage the next time when you're doing a question. So that's why not only the ones you got wrong, even the correct ones, read the report fully. Okay. Requirements are fine, but still make sure like, different exams got different conditions. English is different, math is different. So make sure you know exactly what need to be doing in the exam, reading times, everything clear. See, how do you see reading time? So now, Lynn, when you're doing the past exam papers or trial exams, so what do you usually do in the reading time? What's your plan? Now, Lynn, what do you do in the reading time usually? Can you hear me? You're muted. It's okay, I'll pass it on. Ren, what do you do in the reading time? Do you actually read them fully or you try to work out some questions? What's your plan?
I check which questions I can do that are easier.
Good. I mean, usually, like, first thing is read. Like, read the full exam, like, very quickly. It's like probably within 3 minutes or within 4 minutes, like a quick read, like a quick scanning what's in the paper. And then when do the second run, and that's the place you try to understand the questions, and maybe you can pick the questions you can do or you can start because it's say a lot of time. So you can pick some questions, even if it is extended response. So pick the ones. I'm going to start with question number 3. Maybe this is better. Next question is question number 2. So whatever it is, just order them. Doesn't have to be all of them. Don't stress out within the reading time. Just do maybe 2 or 3 picks to start with. Once you start, you can change over later on. And also for the multiple choice questions, some students tend to work out some of the answers without writing anything. So if you can fix, a few questions up, then once you start the exam, you can quickly answer these questions. So a few things, because 15 minutes is quite a lot of time. So if you manage your time effectively, and you can actually use it properly, to answer the questions. All right, so this ones, you make sure take the rulers and everything, because sometimes we need those little things, the rulers, erasers, pencils, but try to use the pen in the exam. And that's a very common question as well. Should we use the pens in the exam? Recommended to use pens, because that's the best way, because no one can erase your content. Because sometimes when you're rubbing the papers and maybe your writing's not going to be visible enough. And when you do the graphings, I recommend to use a pencil. And once you finalize your answer, still draw with the pen. Until then, if you're not sure, use a pencil. Once you finalize, then use a pen and finish the question. And yes, this is, I mean, sounds silly, but it happens a lot. Sometimes they mix up the dates. You assume that my exam for the English is tomorrow, you know what I mean? And then like when you realize the time changes, so precisely maybe write your timetable on your table or maybe on your phone and have a look carefully which time, which day we have the exams. And yep, transportings don't get delayed for the exams. Make sure a bit earlier than usually go to school because things can happen, accidents can happen on the road. So make sure do things earlier. All right, there are basics in there. Now, these are some of the common mistakes and things to focus that I noticed when I was marking the papers. We'll do one by one just to have a good look. First one, Sokotoa, I think we know what they are, but these ones, revise them because we think we know them. We have done them like year 8, year 9, year 10. Yes, we know it, but still pick few questions and try them because sometimes if you haven't done them for a long time, when you get a question, you get confused. It's like a little fresh question because you haven't probably done much with the similar triangles recently, areas of a triangles. Sometimes example, even the area of a circle. Sometimes you can forget, maybe circumference. maybe because I think I did one question with the class yesterday. What is it? Area of trapezium. Sometimes we stuck with these questions. They're not hard, and you can't even say, "Oh, we haven't done these ones this year," so you can't say that because they assume that you came to year 12 doing the year 8, year 9, year 10 content. So they think or assume that you know the basics. Yeah, so make sure to revise the basic area concepts. All right. If the question asks simplify, you must simplify. Get the simplest. You can't just leave any large answers. So simplest possible answers. And some questions see these words. State. What's the state means? You just need the answer. See the difference between the simplifying and the state. Simplify means simplest. State means just get the answer as it is. Yes. Exact values, decimals, very common mistakes. When I was marking the papers, I noticed they ask exact, you didn't even notice a word. When you read the question, these are common words you should scan and highlight them. They're exact, it must be exact. The next one, units. Yes, if you don't have units, always say unit or unit squared. Example, sometimes you get the questions like areas under the curve. And then, which is maybe approximate areas. There's no units given. You can always say maybe as is 20 unit squared, or maybe write in words like this. All right, use the brackets properly when solved by CAS, because I still notice when you use in the, especially TI Inspire, the blue calculator, if you type in like maybe 2a plus, just say 7 equals to 12 or something, or 20. Every time, try to put the multiplication. And I notice like even here 12, they're not putting multiplication between letters and the numbers, and they're stuck in the answers. They go, oh, different answer. I couldn't get the answer. The only reason is he didn't put the multiplication between. Very easy things. You can easily avoid. Okay, the next one. Yep, domains. Sometimes we very excited and we know how to sketch the graph, we sketch it and walk away. But there's a hidden domain, or maybe the domain has been mentioned in the question at the very beginning. So make sure, stick with the domain. This one, hence. What's the meaning of hence? If you see a question, usually this is like not the first part, either second part or afterwards. If you see the word hence, you must use the previous result somehow. You must. If you use a different method, if you get the right answer, no marks given. Because clearly says it's a hence. You should use the previous step. Some question they might say hence or otherwise. If you say hence or otherwise, you can use the previous result or any other method. So be careful, read it clearly which ones they're really asking. All right, now, yeah. So in the exam too, you're not allowed to write the CAS syntax. You can't just say example like if you want to solve like equation, you can't say solve 2x plus 1 equals to 5 comma x. You maybe can get the answer, yes, but you can't write these sort of things on the exam because they think that this is a CAS syntax. You can just write the equation, use a calculator, get the answer for x, but do not write the CAS syntax. Yes, and the finite integrals for the plus c, if it is definite or definite, what's going to happen? You put the limits, which means you don't have to put the plus c. Keep answers in positive powers when possible, but if you're rushing with the questions, if you like, running out of time, that's okay. But every possible steps to make you pass positive. Final answer, not the steps in between. All right, now rationalizing, I believe you can remember rationalizing, which is if I do a simple question really quickly. Example, maybe 3 over root 2. So rationalizing means removing the thirds from the denominator. So you can see root 2 in denominator. To remove that, you multiply the top and the bottom by the root 2. What's the answer? 3 root 2 divided by, what's a root 2 times root 2? It is root 4, literally becomes what? 2. Can you see the answer? We don't have thirds in the denominator. So that's called the rationalizing. Oh yeah, this is another common mistake. Average gradient, instantaneous gradient. So make sure if they're looking for the average, we need to have 2 points. And instantaneous means only one particular point, which is same as the dy over dx. Cool. And reverse sets and the Venn diagrams, you have done them like since year 9, but make sure you know how to do the union, intersection, dashes. They're common. Now, number systems. This is very important, mainly for the multiple choice questions. And some answers are very similar looking. And then only difference is they say X is element of N, X is Z, X is Q. So what's the N means? Anyone? If you know it, you can tell me. Who's going to help me out? N? N means the natural numbers, which is all the positive whole numbers. So starting from 1, 2, 3, all the way. And what's Z? Z is the integer or integers, which is positive and negative whole numbers, including the 0. See, like 0, 1, 2, 3, all the way. And this side, -1, -2, all the way. And Q means the rational numbers. R means the real numbers. So if you're not sure, make sure to revise them. They're all in the notes in your textbook as well as our notes as well. Now, the last one. If I say n is any integer, and if n is any number, it could be even, it can be odd. We're talking about the 2n. So what does it mean if we try this way? If I say n, 2n, 2n plus 1. If n is 1, 2, 3, 4. What's the values? What are the values for 2n? N is 1, 2n becomes 2. And this becomes 4, 6, and the 8. Can you see all these answers? They become even. So which is, it doesn't matter what's the n value. If you find the 2n, it's going to be always even. Likewise, 2n plus 1 becomes, they're literally odd numbers. So that's the way to write it. N can be any number. 2n is always even. 2n plus 1 is the odd. Not the down. Yep. If you want to write anything down, just write it down before you move on. And also ask any questions. We haven't done questions yet though, but any troubles, just discuss. These are a few easy questions. How about if I ask all of you to try 1 to 4? I'll probably give 2 minutes. If you know the answers, put them on the chat. Or maybe you can talk. That's fine. Either option is fine. And you try 1 to 4. 2 minutes. Let's talk about the implied domains. You know what it means. That's a hidden domain. Dulaj, what do you think? The first one? Number 1. Just do the number 1. Probably explain the first one after that. Dulaj, what do you think? As you think. It doesn't matter. You can put on the chat. Sound with me? How did you go with the first one? Maybe the first one. I want to see like how you go through with that.
Like greater than or equal to 3.
Yes, it is. Yes, it is. Perfect. I mean, usual technique is what? If you see any root numbers inside the root, it can't be negative. It can be 0 if it is in numerator. So one more technique is you can really grab anything inside the root and has to be greater than or equal to 0. So that's the technique to write it. So which is, that's your answer. Perfect. Number 2, the same technique, but it can't be equal. Why? Because 1 divided by 0, it becomes undefined. So because of that reason, you can do exactly the same thing, but without the equal sign. So x minus 3 greater than 0, x is greater than 3. And number 3. So number 3 doesn't have a root, which means you can have negative, you can have positive. The only thing you can't have is the x equals 2. Because when x equals 2, what happened? It becomes 0, become undefined. So you can say all real numbers except 2. Except 2. Number 4. Use the same technique, but bit more things involving, which is x squared, take away 4, greater than or equal to 0. And then factorize it. The factors are x plus 2, x minus 2. And then the values, you end up getting 2 and the negative 2. So you can see it's a positive parabolic shape. So if you draw the number line, the sign diagram, you end up getting something like this. So in the question asking greater than 0, which is where your sign diagram is positive. Where is it positive? That's positive, that's positive, that's negative. So answer for this question is x has to be less than negative 2, less than negative 2, or x is greater than 2. So if it is nonlinear, if it is a quadratic, cubic, or anything, try to factorize it. And then draw the number line with sign diagram. You can easily answer the question. Is there any troubles, anyone? Is that all good so far? Yeah.
Wouldn't that include 2 as well? Because that's where 0, it's like greater than or equal to 0.
You can, yes, it is. Yes, it is. You're right. Because it's a positive plus 0, isn't it? Yes. Perfect. Thank you. Cool. That's good. All right. We'll do one question in the hybrid or the piecewise. I'm not going to pick too many questions. Just probably grab one each just to make sure we know the concepts. Okay. All right. Let's try the number 5. So piecewise functions, usually different domains. I mean, sometimes we think piecewise functions need to get connected. Doesn't have to be. You can have separate functions within the graph. It doesn't have to join, because otherwise we try to join somehow. Doesn't have to be. All right, so first equation, y is equals to x squared minus 1. So make sure draw the x squared minus 1 is going through negative 1. It's a parabola. Or something like that. What are the values? That's a negative 1. And intercepts, which is neg 1 and the 1. So you can see the intercepts are there. And now what's the domain for this one? Neg infinity up to 0. So pretty much we need from this end all the way up to that point, inclusive. So that's done. You don't need the rest. And then x minus 1. So y equals x minus 1 is a straight line, which is intercepts are x equals 1, y equals negative 1. So literally going through the same 2 points. What's the restriction? From x equals 0 to 4. So you draw the line, straight line from here. It goes only up to x equals 4. Cool. So that's what it looks like. Can you figure out what's the y value at the moment? So sub x equals 4 into the second equation. What's the y value? 4 minus 1 becomes just 3. And then what's the last one? Y equals 3. That's a horizontal line going through y equals 3. It's going through here, but starting from 4. So you can see this is the full graph. Label everything. Endpoints are fine. And this is 4, 3, 0, negative 1. Just label everything clearly. I'll ask a few more questions with the same graph just to get an idea. And for the same question, can you think of doing the domain and the range? And also, I'll ask this way. Find the x values for the gradient to be defined. There are three sections. So same graph, domain, range, and find the x values for the gradient to be defined. Okay, I think I need the answers from you guys now, so I'm not gonna tell the answers. Just put on chat if you know it. Or maybe you can tell. You can talk. That's the whole idea. It has to be interactive. So I got one answer. Domain is all real numbers. Perfect. Because you're going to go for the negative infinity all the way up to positive infinity. Perfect. That's good. And let's see the range. Range, the lowest value is -1. Yes. And up to, you see all the way goes to infinity. Yeah. Perfect. But make sure include the -1 because it's touching the at -1. Eh? So including -1 up to positive infinity. And then, can we define the gradient at any point or maybe some points? I mean, this is same as, sometimes they can ask questions like, is a function differentiable? So find the x value for the gradient to be defined. What do you think? All right, so I got one answer. It says everywhere except the connecting points. That sounds good. So you're going to say like all real numbers except curly bracket, x equals 0 and x equals 4. If this is the answer, what's the reason of having that? Why? The reason is those 2 points, I'm talking about these 2 points here, this and that. The reason graph is connected, that's perfectly fine. But the issue is at that particular moment, when they're connecting, they're not smooth. Smooth means they don't have the same gradient. If this point is connecting like one graph coming this way, other graph going this way, can you see they connected smoothly? Or maybe one graph this way, other graph connecting this way. So you can see smoothly connected, which means at that particular point, you have the same gradient. Then that can be defined. But the issue is this one and that one, they don't have the same gradient. Means not the same slope, means those 2 points are acting as cusps, which is the sharp connection or the point. And that's why you can't include these 2 points. Perfect. Okay, when you get a question, good to analyze differently and think what else they can ask. And that's how I do questions, because in the exams, when they create the questions, they think the same way. How do we ask a different question from the same concept? So if you think ahead, maybe you are the winner. Cool. All right, let's move on. All right, bit of the theories, and these are needed for the exam one as well. We haven't seen much questions for odd and the even functions lately. They're part of the study design, but still they're not asking questions recently, but they can ask anytime. Yeah. What do you think? What are the properties of the odd and even functions? Odd and even functions. Both odd and even functions, they're going through the origin. That's a must. So if I just say little note, Just say odd functions, even functions. So one property is like if you sub the negative x as it becomes positive, that's even. And this one, if you sub the negative value, as you get in negative f of x. So that's how you realize the odd even function. And also they're both going to go through 0. I'm going to write this way. So that's the similarity. Anything else? Perfect, Dylan. Yep, that's perfect. And then what's next? What's next? Easier way to analyze this. If it is even function, maybe think, oh, I'm talking about a parabola, basic parabola. And if it is odd, maybe think of doing the cubic, basic cubic. So all the features are valid. I'm going to say when my x is going to positive infinity, what happened to my y? Also going to positive infinity. Sorry, y value. Y goes to positive infinity. And then when x goes to negative side, till y is going to positive. Can you see like still it's increasing? So those are the features for the even functions. And then how about the odd? If x is going to positive, y goes to positive, perfectly fine. But if x goes to negative, then y goes to negative infinity, not the positive. So those are the similarities and the differences between the odd and even. Just note that down. Add them to a bond book, just memorize them if you don't know it. Then I'll let you try the 7a and the B. Sorry, A and the 2. That's not B. Hi, General. You connected? Yeah, connected.
Classes are late.
That's okay. I'll try the first question together. Maybe you can do the second one for homework. All right, first one is simply what you have to do is sub the negative x. So f negative x, which is bracket negative x cubed minus negative x. And what's the negative x cubed? Negative x times negative x times negative x, which is still negative x cubed plus x. Then they're not looks the same. But how about if I take negative out as a common factor? X cubed minus x. What's the answer? X cubed minus x. We know what this one is. Just same as what? You're given f of x. Isn't it? So you can replace that whole lot with the f of x. See, my next step is so negative at the front, and this becomes f of x. See what happened? We sub the f of negative x, my answer becomes negative f of x. So which is what? Even or odd? It's a odd function. So that's a method of approaching it. Not the done.